Okay guys, so today we're going to be learning another way to factor. I know, we're getting so sick of this, right? Today we're going to be learning something called factoring by grouping. Factoring by grouping, section 510 in your Dolciani book. So sometimes quadratic equations or quadratic expressions have more than 2 or 3 terms. And so we've done 2, the difference of squares. We've done all that through those 3 with trinomial factoring and perfect square trinomials. But sometimes when there's 4 or more terms, you're going to do something called grouping, and that means grouping things together. In order to be able to do that, we need to be able to do a couple of things. We need to be able to recognize a GCF when the GCF is an expression. So looking at this first example, I kind of recognize that this x plus y and this x plus y are the same. Well, in this expression, they are the greatest common factor, the GCF. So I would pull that out to the front. What would I be left with? I'd be left with a 5 and that w. So 5 plus w. Now actually, if you look at that, I've got 2 binomials, so I actually have factored it. I factored out the GCF. All right? That's one way. We also, yikes, what just happened? Sorry. We also have to be able to recognize a concept of something called the opposite. Okay, and I looked at this and I was like, oh gosh, yeah, could I distribute and then kind of work backwards? I absolutely could, but also recognize that 3 minus a and a minus 3 are opposites. So I actually can make them exactly the same by taking out a negative 1 out of one of them. So I looked here and I said, you know what, I'm going to pull out a negative 1. So I rewrote as 5a minus 3. Now, when I pull out a negative 1, I have to multiply it to this guy, so it becomes plus 2a. And when I pull out a negative 1, that 3 becomes negative 3, and that a becomes positive a, which is this. So I just rewrote it. Okay? All right, now I see a common factor. That common factor is a minus 3. So I'm going to pull out the a minus 3, and I'd be left with 5 plus 2a, these outer terms here, okay? And there again, I have actually factored out the GCF. All right, now one thing I want to remind you about in this situation is if you're unsure of what you're going to be left with, remember, take your GCF, which we said was a minus 3, just divide it to both terms, and that's going to be what you're left with, so 5 plus 2a. Okay? All right, let's make it a little bit harder. All right, so now factor by grouping. I look at this and I see 4 terms. If you're given 4 terms, right now, the only way you're going to learn how to do this is to factor it by grouping. So grouping means group together pairs of things or more than that that have a common factor or a pattern you recognize. So I looked at it and I was like, okay, x cubed and x squared have a common factor, and 2x plus 2 have a common factor. All right, so let's see what we do. We factor out the GCF of the pairs that I put together. So this GCF would be x squared. I pull it out, and I'd be left with x plus 1. I pull out the GCF here, and I'm left with, which is 2, and I'm left with x plus 1. Now, in order for the grouping to be correct, these 2 binomials you got have to be exactly the same, because now we can factor by pulling out a GCF. If they're not the same, then there's no GCF. You may have to look at different pairs of things that connect. All right, so now we take out the GCF, which is x plus 1, and we're left with x squared plus 2. Now, remember, I'm always saying factor completely. If this were something that could be factored, or this was something that could be factored, then you'd have to keep going. All right, looking at another example like that. All right, we're like looking at pairs of things. Okay, so I looked here and I was like, all right, those have a common factor. And if I pull out the common factor of x squared, I'm left with x plus 2. I don't see any common factor here, but I'm hoping that you recognize that maybe x minus 2 and x plus 2 are opposites. This is a really great case for you to pull out a negative 1 to make the opposites the same. So if I pull out a negative 1 out of both of these, I'm going to pull out a negative 1 to the front. I'd be left with x plus 2. Pulling out the negative 1 changes both of those to the opposites. Now look what happened there. I got two binomials that are exactly the same, so now I have a GCF to factor out. Okay, so I factor out an x plus 2, and I'm left with x squared minus 1. Oh, my goodness. Coach Fred said, pull out the greatest, or always factor completely. So now I've got x plus 2, and this is the difference of squares. So x plus 1, x minus 1. Okay? All right, so that's grouping. Now, grouping can be harder. Grouping can be harder because sometimes we have to really pay close attention to sets of numbers and see if we can recognize perfect square trinomials and difference of squares. So I looked at this and I was like, okay, so just watch right now, no writing. I looked and I was like, oh, these guys have a common factor of a 4, and these have a common factor of an r. Okay, so I pulled out the 4, and I was left with p squared minus q squared, plus I pulled out an r, and I was left with 4q minus r. These are not the same, so this has done me no good, okay? So then I move around, and I try different patterns, or different pairs of numbers. I was like, okay, what else could I could probably put these guys together and these guys together. So if I did, it would be 4p squared minus r squared